Good day everyone, my name is Muhammad Amirul Naim. Today I will present a solution for a local herbs company that needs to determine the production volume for the three types of packaging box. Box W, X and Y, we are given specific material contract for cardboard, plastic and foil, and we will solve this using the matrix inversion method. Second, we have do a setting up the question. First, let's define our variable. We will let A represent box W, B represent box X, and C represent box Y. Based on the data provided in the table, we can form the following system of the linear equation. For cardboard, 8A plus 5B plus 3C. Calculate, we get a 91. And for plastic is 4A plus 9B plus 2C. Calculate, we get 8. So the last one is for foil, 7A plus B plus 6C. Conclusion, 83. So second method is matrix representation. To solve this using matrix, we represent the system as AX plus B. Our coefficient matrix M consists of the material units per box. X is our column vector of ACNO A, B, C, and B is our contents vector representing the total available.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Farid Kebbi Ahmad and I'm from DPD 2A, and I will continue with question number 2. The herb farmer record the daily water usage for basil, mint and rosemary over 3 days in matrix A, with the first row being 5, 3, 2, the second row 2, 7, 1 and the third row 1, 4, 6, which when multiplied by the daily water usage variables in matrix S equals the total consumption for each herb of 28, 23 and 18 liters as shown in the matrix equation A times S equals B. Next, to find the inverse of matrix A, we calculate the determinant using the Cyrus method by summing the product of the positive diagonals. 5 times 7 times 6 plus 3 times 1 times 1 plus 2 times 2 times 4 to get 229. Then subtracting the sum of the negative diagonals, 2 times 7 times 1 plus 3 times 2 times 6 plus 5 times 1 times 4, which is 17, resulting in a determinant of 159. Next, we determine the adjoint matrix by taking the transpose of the cofactor matrix, resulting in a new matrix where the first row is 38, negative 10, negative 11, the second row is negative 11, 28, negative 1, and the third row is 1, negative 70, and 29. Finally, the inverse matrix A, negative 1, is found by multiplying 1 over 159 by this adjoint matrix. Last but not least, to find the values of matrix S, we use the formula S equals A inverse times B by multiplying 1 over 159 with the product of the adjoint matrix and matrix B containing the values 28, 23, and 18. The multiplication is performed row by row. Row 1 is 38 times 28 plus negative 10 times 23 plus negative 11 times 18, giving 636. Row 2 is negative 11 times 28 plus 28 times 23 plus negative 1 times 18, totaling 318. And row 3 is 1 times 28 plus negative 17, times 23 plus 29 times 18, which equals 159. Finally, by deriving these totals by the determinant of 159, we arrive at the final answer for matrix S with value for 2 and 1, confirming that water used was 4 liters on day 1, 2 liters on day 2, and 1 liters on day 3. That's all from me. Thank you.
Hello, my name is Muhammad Fikru Muazzim bin Ismail from DPD 2A. So today I will be presenting a question on Cramer rule based on a situation called herb packaging order. In this problem, a shop sells 3 types of herb, which are thyme, lemongrass and lavender. On a particular day, 3 different customers place order with different combination of these herbs. Our objective is to determine how many packs of each type are needed in total. First, we define the variables. T represent the number of thyme packs, G represent the number of lemongrass packs, and L represent the number of lavender packs. Now, based on the order details, for the first order, the customer ordered 4 packs of thyme, 1 pack lemongrass, and 2 packs of lavender, with a total of 21 packs. For the second order, the customer ordered 3 packs of thyme, 5 packs of lemongrass, and 1 pack of lavender, with a total of 26 packs. For the third order, the customer ordered 6 packs of thyme, 2 packs of lemongrass, and 3 packs of lavender, with a total of 33 packs. For this statement, we can form a system of linear equation. The first equation represents 4 thyme plus 1 lemongrass plus 2 lavender equals 21. The second equation represents 3 thymes plus 5 lemongrass plus 1 lavender equals 26. The third equation represents 6 thyme plus 2 lemongrass plus 3 lavender equals 33. So, we now have a system of 3 equations with 3 unknowns. So next, we can solve this system using Cramer rule to find the values of thyme, lemongrass, and lavender. In conclusion, the important steps in this problem are to define the variables, translate the word problem into equation, and then solve the system using an appropriate method. This is all from me. Thank you.